Welcome to Physics Essentials. Today we will be looking at how to plot graphs. This is part 2 of 3 videos where we look at the Simple Pendulum Graphs, which is a part of the CSEC Physics syllabus. So now we're going to look at some guidelines for plotting graphs. The first guideline is that you want to record the experimental data or the data that you're going to use to plot your graph in a table. Usually you're given some experimental data and you're also asked to complete a table. You will look at your table and determine the minimum as well as the maximum value for each variable to be plotted. Then you would choose a suitable scale for each axis in order to include all the data that you have in your table. You also want to choose a scale that will allow you to maximize the use of your graph paper, where you're using at least 75% of the graph paper. The points that you are going to plot on your graph can be plotted as a small x or as a dot, but you want to circle that dot, otherwise it would be very hard for you to see the point that you would have plotted. You want to do this using a sharp pencil. So you're not plotting your graphs using a pen, but a pencil. When you are drawing your line of best width, so after plotting your graphs, you're going to draw a line of best width for straight line graphs. You do not connect to these points as though you're drawing a line graph. You draw a line that will form as a trend of your data points. So let's look at an example. So here you have a simple pendulum graph question. It says a student was asked to find acceleration due to gravity using a simple pendulum. She varied the length of the pendulum and found the time for 20 oscillations. Her results are presented in the table below. So right there you're seeing the length of the pendulum, the first column. Then you're seeing in the second column the time for 20 oscillations. So when the length of the pendulum was altered, so the length was increased by 0.1 meters or 10 centimeters, you realize that the time for 20 oscillations increased. So when you increase the length of the pendulum, the time for 20 oscillations increased. So now we are going to use these values to find the time for one oscillation. So the time for one oscillation would simply divide the time for 20 oscillations by 20 to get the time for one oscillation, and this is known as the period. Then to find the period squared, we would simply multiply the value that we get for a period by itself. Squared means that we're multiplying the number by itself twice. And so after doing that, we would get the period squared and we would record these values in our table. So 6 marks is awarded for completing the table. Then part B says that we should plot a graph of length of the pendulum versus period squared. We use a L to represent the length of the pendulum and T squared to represent the period. After we plot our graph, we're going to find the slope of the graph. So let's first complete the table. So after completing the table, you should get values close to these ones that you are seeing on the screen. So now we would have completed the table, so we can move on to part B, where it says that we should plot a graph of length of the pendulum versus period squared. Now based on the instruction, we can identify the variable that should be plotted on each axis. So we examine our table containing our data, and we will now know which variable is going on our y-axis and which variable is going on our x-axis. Since it said that you should plot a graph of length of pendulum versus period squared, it means that length of the pendulum will be on your y-axis and period squared will be on the x-axis. So we're focusing on those two columns of our table. So we're going to look closely at the values that should be on each axis, and we're going to decide on a suitable scale. Remember that the scale that we choose should allow us to use most of our graph paper. So we're looking at the length of the pendulum. So looking closely at the values, we're seeing where they're increasing by 0.1. So 0.1, then 0.2, 0.3. So we're seeing that trend there. So we can more than likely go up by 0.1 in this case. For period squared, we're realizing that the values, so looking closely at them, you'll see that they're increasing by approximately 0.4. So if you should subtract these values, you're seeing that there's an overall increase of approximately 0.4. So we could consider that value to use on our scale. So let's go to our graph paper and decide on a suitable scale. So here we have our graph paper, and the scale that we've decided on would have been 2 centimeters. So for every 2 centimeters on our graph paper, it would represent 0.1 meters. And that is for our y-axis where we're plotting length. On our x-axis where we have period squared, we would have 0.4 for every 2 centimeters. So this would be 0.4, right here would be 0.8, right here would be 1.2, 1.6, 2, 2.4, 2.8. Now this is important because what I realized some persons do is that they will take the values directly from the table and put it on their graph. If you do so, that is not correct. You notice I did not take 0.41 from the table and put it on the graph, and then 0.81 and 1.21. No. You are using a scale, and so you have to increase by the same amount each time you move the same number of places. So each time you move 2 centimeters on your x-axis, you should increase by exactly 0.4. So you can't be moving 2 places each time and then you're going up by 0.5 at one point and then 0.4 at another point. You have to be consistent. So each time you move 2 centimeters, say 2 centimeters, you are increasing your value by 0.4 because that is your scale. And ensure that you're moving exactly 2 centimeters. A common mistake is that students move 3 centimeters one time by mistake and then move another 2 centimeters without even realizing. When you do so, it's going to throw off your scale, your values. It's going to throw off your values for your data points, and then it's going to be hard for you to find a best fit line because one or two of your points will be off as a result. So let's now plot our data points. So we have our scale, and it will allow us to use most of our graph paper. Also, something I must highlight is that you don't want to use 3 centimeters. 3 centimeters is tedious for you to plot the points, so you're advised not to use centimeters. So try to use 2 centimeters or 1 centimeter. So do not use 3 centimeters, or else you're going to need your calculators to help with finding the positions for your data points. So now we would plot our points. So on our graph it says plot the points on the graph. So you know which variable is going on which axis. So you want to be sure of that. You could put on your axis label. So notice the axis label. It has both the name of the quantity as well as the unit. So you want to put on your axis label so that you don't run in any issues confusing the axes. So length is on our y-axis, period squared is on our x-axis. Then we're going to plot our points. 0.1 corresponds with 0.41. So 0.1 on our y-axis corresponds with 0.41 on our x-axis. So you have 0.1 on your y-axis and it corresponds with 0.41 on our x-axis. But some persons might be saying, but right here is 0.4. So, but this point is 0.41. So now you need to identify what's the value for one of the small boxes here. So if you want to find the value for one of the small boxes here, since you would have moved 10 boxes, so if you plot this on your graph paper and you count the number of boxes between the point 0 and 0.4, you would get 10 small boxes. So in order to find out the number for one of them, you would divide 0.4 by 10, and that would give you 0.04. So that means if you move from 0 to one of the small boxes after 0, it would represent 0.04. So one small box after 0.4 would give you 0.44. So that is why you don't want to put your point all the way over to the other small box, because if you do, that point would be 0.44, which is greater than what we want, which is 0.41. So you can estimate it, put it somewhere in between, or you can round it off and put it at exactly 0.4. That would be fine. That is what was done for the other points. 0.2, so we found 0.2 on our y-axis, and see where it corresponds with 0.81 on our x-axis. Right here. Then we have 0.3 and find 1.21. So 0.3, 1.21. And remember, if you carry it over to the next point, the small box that falls immediately after 1.21, that point would be 1.24. Because each of the small boxes on our x-axis is 0.04. So you want to be careful with that. For 0.5, the length is 0.5 and the period squared is 2.02. So this would be halfway in between this 2 and the small box that follows 2. Because the small box that follows 2 would be 2.04. For 0.6, it would be 2.43. You can put it over to the other small box or close to it, because that box would be 2.44. And this is how you would plot your data points. So after plotting your data points, you want to then draw your line of best fit. So you have your data points and your graph would look something like this. Then you would draw your line of best fit. Now, your line of best fit is a straight line and it should extend beyond your last data point. So don't draw your line of best fit and stop it at your last data point. You want to extend it beyond your last data point, so that if you're asked any question to tell what would be the length when the period is 3 or 3.2, you can get that information from your graph because you would have extended your best fit line. And another thing to note, your best fit line will not always pass through the point of origin. It is based on where your data points are. So if your data points are closer, are on this side of the line going up, that means that's where you're going to start drawing your best fit line from. So your best fit line will not always pass through the point 0, 0. So don't try to force your best fit line to go through that point, because it will not always pass through the point of origin. It depends on the trend of your data points, and that is where you will draw your best fit line. You also want to draw your best fit line where it's touching most, if not all of your data points. But if it doesn't touch most or all of them, ensure that you have the same number of points on either side of the line. So the same number of data points should be on either side of the line if these data points are not going to fall directly on the line. In the next video, we will be looking at how to find the gradient of this graph, so be sure to watch that one. This is our completed graph, and you will notice that it has the title, your scale, your axis labels, and your best fit line. Thank you so much for watching.